Okay, this is going to be a more challenging problem because it's going to require us to combine our understandings of conservation of momentum, forces, and kinematics all together to answer this problem. So we have a car. I'm going to start with my picture. So I have a car. That's a car, A, and it is moving east with a velocity of 20 meters per second. So I have the mass of car A is 500 kilograms, and the initial velocity of A is 20 meters per second. It is going to collide with a stationary car, no, sorry, truck B, and so the mass of B is 1,000 kilograms. And the initial velocity of B is going to be 0 because it's stationary. It is then wanting us to find the combined velocity after the collision. It tells us that after the collision, the combined system is going to slide 35 meters before coming to a stop due to friction, and it wants us to find our coefficient of kinetic friction between the road and the tires. And then we need to determine how long it is going to take the cars to come to a stop. So in this problem, we have an inelastic, because they stick together, collision. We are going to need to use a conservation of momentum, where momentum is mass times velocity. We are going to need to use forces, specifically the frictional force, because it's asking us for a coefficient of kinetic friction, and we are going to need to use kinematics. I'll determine which kinematics equations to use when we get there. Off the top of my mind, we have these. So let's get started. The first thing, part 1, wants us to find the final velocity. I'm going to put that in a box because if I don't, I'm going to completely forget what I'm solving for. So because we want to find the velocity of the combined system immediately after the collision, I am going to use my conservation of momentum for this system. So I have the initial momentum of A plus the initial momentum of B, and this is going to result in a combined collision because they're going to stick together. This is inelastic. During this collision, they're going to stick together. They're not going to bounce off of each other. So I will now replace this with the mass of A times the initial velocity of A plus the mass of B times the initial velocity of B is going to equal their combined mass times some final velocity of these cars. And what I'm solving for is the final velocity of the cars, so I'll just rearrange this. And plug in my values. So 500 times 20. And then I don't need to take into account the initial momentum of that second car because its velocity is 0, so that'll just go away. And we'll divide by the combined mass, which will be 1,500. This gives me a final momentum of about 6.67 meters per second. And since the initial car A, was moving in the positive direction, car B was stationary, they're going to continue moving in the positive direction together. So our answer for 1 is 6.67, or I'll do it in a different color, 6.67 meters per second. Now we want to find the coefficient of kinetic friction between the road and the tires. So I'm just going to draw a line here. Part 2 is asking us to find our coefficient of kinetic friction between the road and the tires. So I know that I need to consider a force diagram here. This is the truck. That's the car, A, B. On this entire system, I'm going to put them in a block together because I can consider them moving together. So I will have mg down, normal force up. I'm going to make this a capital M because this has to be the combined mass of the two. Because my equation for friction only considers the normal force, I'm only going to draw the y direction on here. This is because the x direction is not going to contribute anything to my normal force because we are on a flat surface. The next thing that I want to do is I want to use Newton's second law, F is equal to ma, and this will be the combined mass of the system. And I'm going to consider the only force that is acting on these two is going to be the frictional force that is slowing them down, right? They are moving forward. They have forward acceleration, but this forward acceleration minus the force of friction is going to bring them to a stop. So the combined mass has to be equal to the force of kinetic friction. I'm going to replace this with mu sub k to represent the coefficient of kinetic friction. I have my normal force. My normal force is equal and opposite to the weight of these two together. So I have capital M A is going to be equal to mu sub k, capital M G, because M is on either side, it cancels out, mu k G, and I find that my coefficient of kinetic friction is equal to acceleration divided by G. I know that G is 9.81 meters per second squared, but I don't know what my acceleration is right now. So I need to find a way to find this acceleration. Because we're going to start with some initial velocity. That initial velocity is going to be the velocity that we found after the collision. And when it comes to a stop, it will have a final velocity of 0. Do I have any other information? I also know it's going to slide, that this distance is 35 meters. I can use a kinematic equation. I can use a kinematic equation because I have initial velocity, I have final velocity, I have change in x. I want to find the acceleration, so this would work really well for this specific kinematic equation. So I'm going to rearrange this to solve for a, meaning 2a delta x is going to be equal to my final velocity squared minus the initial velocity squared. So my acceleration is equal to my final velocity squared minus my initial velocity squared divided by 2 delta x. Because my final velocity is 0, right, because it comes to a stop, I can simplify this. So I have negative initial velocity squared divided by 2 delta x. My initial velocity was 6.67. And I want to make sure that I have my square separate from the negative sign because I am only squaring this value. I'm not squaring that negative sign there. That is a common mistake that people make. That's why I'm pointing that out. So our acceleration is going to be equal to negative 44.5. I'm going to round. We might have a rounding error, but it'll be okay. It'll be small. So 44.5 divided by 70 is going to give us an acceleration of 0.636 meters per second squared. We'll just plug this in, and we get that our coefficient of kinetic friction is going to be 0.636 divided by 9.81, and it is going to be 0.065. And that's our solution. So the next thing that it wants us to solve for is it wants us to figure out the time or how long it's going to take for these cars to come to a stop. So to do this, I'm going to use kinematics. I'm going to use kinematics because I have that my change in position is 35 meters. I have my initial velocity is 6.67 meters per second. I have that my final velocity is 0. I have an acceleration that is 0.636 meters per second squared. This all sets me up to use a kinematic equation to solve for time. So I could use velocity, no, I can't use that. I could use x final is x initial plus VIT plus 1/2 acceleration times squared. I don't really want to use this, even though I could, because this is going to require me to use the quadratic equation. I'm going to save the left hand of the screen for a simpler version, but I will walk through the quadratic equation just in case you need to see how to work that out. If you don't need to see how to work that out, please skip ahead. This is going to take a long time. So I'm going to move my initial position over to the other side so that I can get a delta x, VIT, plus 1/2 AT squared. I'm going to rearrange this so this actually looks like what I expect a quadratic equation to look like. Sorry, that was my dog. So in this situation, A is going to be 1/2 A, B is going to be my initial velocity, and C is going to be negative delta x. It's negative delta x because the quadratic equation doesn't have this minus sign here, so we need to take that into account. The next thing that we're going to do is we are going to do that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My was it 7th grade? No, I had to be 10th. My 10th grade math teacher, Miss Miller, from Jeff City High School, is going to be very proud that I still remember this based off the song she sung for me. Because it has been a good 15 years. So, ooh, more than that. Oh, Lord. Okay, not the point of this video. Negative, my VI was 6.67 plus or minus the square root of 6.67 squared minus a negative is going to give me a positive plus 4 times 1/2 times my acceleration is negative 0.636. My change in position was 35. I already accounted for that negative sign. And this will be divided by 2 times 1/2 is going to be 1 times negative 0.636. And now we just need to punch this in the calculator. I'm going to do it in a lot of steps because I know that if I punch this in the calculator all at once, I'm going to royally mess this up. And I'm going to do a little bit of rounding, which might give us a rounding error, but it shouldn't be significant enough to create any real problem with our calculation. Negative. Oh my goodness, I can't believe this. My rounding above is actually what's going to create this issue here. So I rounded this value. I need to see what my acceleration is going to be without that rounded value because it's so close when I'm solving for time. That I need to have my acceleration as specific as possible because these are so close to each other. So if I don't round, I'm going to put it in green color. The acceleration is going to be negative 0.635557. If I use this instead of 636, let me see what I get. Yep. I get minus 44.48, which would round to 44.5. I'll divide this all by negative 0.63555557, and I get that the time is going to be, this is going to just go to 0, that'll go away, is negative 6.67 divided by negative 0.63555557, which will be about 10.5 seconds. Now the other way that I can solve this is using this kinematic equation, which will be much more straightforward because my final velocity is 0, my initial velocity is 6.67, I have my acceleration, which was negative 0.63555557, and I want to solve for time. If I rearrange this, I get that time is equal to negative 6.67 divided by negative 0.635557, and my time is going to end up being exactly the same. Either way works, but which kinematic equation I choose, whether I choose 1 or 2, makes a huge difference on how much time I spend on this problem. So I need to use a little bit of intuition and critical thinking to go about solving this. And that's it.